The topic of this video lecture is access methods. Now, first, we will discuss what is a access method. Access method is a program that enables access to data on disks, tape, or other external devices. This is used to access the information in the file. There are two types of access method. The first type is sequential access and second type is random or direct access. Now we discuss in detail sequential access. Sequential access is the reading or writing data records in sequential order, that is one record after the other. In sequential access method, a program skip forward or backward records. It is based upon a tape model of a file. Sequential access in which a data location is found by starting at one place and seeking through every successive location until the data is found. Tape storage is an example of sequential access. This figure shows a sequential access. Next method is a direct access. Direct access or random access is the ability to obtain data from a storage device by going directly to where it is physically located on the device. In direct access methods, based upon a disk model of a file. In this method, any block can be read or written. A direct access storage device has the electrical or electromechanical means to be immediately positioned for reading and writing at any addressable location on the device. Disk storage is the best example of direct access, and this figure shows a random access. Next is allocation methods. Now, allocation methods define how the files are stored in the disk block. This method is to allocate space to files so that disk space is effectively utilized and files can be quickly accessed. Now, there are important allocation methods. These are contiguous allocation, dynamic allocation, linked allocation, and indexed allocation. Contiguous allocation. Now, in this allocation method, contiguous memory allocation is a classical memory allocation model that assign a process consecutive memory blocks, that is memory blocks having consecutive addresses. Consecutive memory allocation is one of the oldest memory allocation scheme. When a process needs to execute, memory is requested by the process. The size of the process is compared with the amount of contiguous main memory available to execute the process. If sufficient contiguous memory is found, the process is allocated memory to start its execution. Otherwise, it is added to a queue of waiting processes until sufficient free contiguous memory is available. In this scheme, each file occupies a contiguous set of blocks on the disk. Now we consider an example. If a file requires n blocks and is given a block B as the starting location, then the blocks assigned to the file will be B, B plus 1, B plus 2, in continuous B plus n minus 1. This means that given the starting block address, and the length of the file in terms of blocks required, it can determine the blocks occupied by the file. The directory entry for a file with contiguous allocation contains number 1, address of starting block and length of allocated portion. Now see, the figure shows start from the block 19 with length equal to 6 blocks. Therefore, it occupies 19, 20, 21, 22, 23, 24 blocks. Now, what are the advantages of contiguous allocation method? Now, first advantage is both the sequential and direct access are supported by this. For direct access, the address of the kth block of the file which starts at block B can easily be obtained as B plus K. And the second benefit is this is extremely fast since the number of 6 are minimal because of the contiguous allocation of file blocks. Now, there are the two drawbacks. The first one is this method suffers from both internal and external fragmentation. This makes it inefficient in terms of memory utilization. And second drawback is increasing file size is difficult because it depends on the availability of contiguous memory at a particular instance. Now, second allocation method is a dynamic storage allocation method. A dynamic storage allocation is to request a size from a list of free holes. The set of holes is searched to determine which hole is best to allocate. First fit, best fit, and worst fit are common strategies to select a free hole from the set of available holes. First fit and best fit are better than worst fit with respect to time and storage utilization. These methods suffer from external fragmentation. First fit allocates the first hole that is big enough. Best fit allocates the smallest hole that is big enough. And worst fit allocate largest hole. Next allocation method is linked allocation method. In linked allocation, each file is a linked list of disk blocks which need not be contiguous. The disk blocks may be scattered anywhere on the disk. The directory entry contains a pointer to the starting and the ending block of the file. Each block contains a pointer to the next block occupied by the file. There is no external fragmentation with linked allocation. Any free block can be used to satisfy a request. There is n need to declare size of file when it is created. A file can continue to grow as long as there are free blocks. It is never too compact disk space. Now, figure shows how the blocks are randomly distributed. The last block 25 contains 1 indicating a null pointer and does not point to any other block. Now, what are the advantages of linked allocation method? Now, this is very flexible in terms of file size. File size can be increased easily since the system does not have to look for a contiguous chunk of memory. And the second benefit is this method does not suffer from external fragmentation. This makes it relatively better in terms of memory utilization. Now, the drawbacks of linked allocation method are: the first is allocation can only be used effectively for sequential access file. Second drawback is it is space required for the pointers. And the third drawback is it is reliable. Next allocation method is an indexed allocation method. In index allocation, a special block known as the index block contains the pointer to all the blocks occupied by a file called index pointer. Each file has its own index block, which is an array of disk block address. Indexed allocation supports access without suffering from external fragmentation. The index blocks is normally on disk blocks, thus it can be read or written by itself. And the figure shows the directory entry contains the address of the index. Now, what are the advantages of index allocation? Now, this allocation supports direct access to the blocks occupied by the file and therefore provides a fast access to the file blocks. And the second benefit, it overcomes the problem of external fragmentation. And the drawback of this index allocation method is the pointer overhead for index allocation is greater than linked allocation. Second drawback is for every small files, the index allocation will keep one entire block for the pointers, which is inefficient in terms of memory utilization.